We are laying the foundations for a new chapter. In 2024, we took the first steps, and throughout 2025, we will go further, not only preparing the ground, but actually structuring and setting up the necessary production lines. Elon Musk is involved in a confidential project that promises to redefine the way we view the long-awaited Tesla Model 2. According to the latest information, this model, expected to go into production later this year, will be able to operate virtually autonomously. Rumor has it that it will be able to detect emergency sirens before the driver does and react in less than a second. In addition, it will be able to purify the cabin air to hospital-like levels, all in real time while driving. Although these features have not yet been officially confirmed, it is speculated that they will be part of the new Model 2. If this comes to fruition, how will it impact our daily lives? And will the Model 2, after so many delays, really be worth all the hype? Welcome to Tesla Universe. We'll take a look at how Tesla is trying to combine affordability with innovation in the design of the Model 2. Many enthusiasts have suggested that the Model 2 will be Tesla's cheapest vehicle to date, with prices speculated to be between $15,000 and $17,000. However, upon closer inspection, this price range seems out of line with the current automotive market, given the costs involved in producing electric vehicles. To better understand, just look at the most affordable electric models available today. The Chevrolet Bolt EV, for example, is one of the cheapest in the United States, costing around $27,000. Even with tax incentives, it is rare for its final price to be below $20,000, without considering extras or resale fees. The Nissan Leaf, another well-established EV, starts at around $28,000, even after years of cost optimization and technological advances. The Hyundai Kona Electric, considered an economical option within the segment, has a starting price of around $33,000. All of these models use lithium-ion batteries, the most expensive component in any electric vehicle. So imagining that the Tesla Model 2 could sell for just $15,000 to $17,000, while offering performance and quality that is on par with today's standards, seems extremely unlikely. To make an EV under $20,000 viable, Tesla would need to overcome significant challenges. The first is the cost of batteries. Reducing this cost would require adopting low-cost technologies, such as more refined lithium iron phosphate, LFP batteries, or the use of innovative 4680 dry electrode cell technology, which promises greater energy density and lower production costs. Even with advances in manufacturing, such as the use of gigacastings and structural battery packs, as well as high-level automation, there is still a limit to cost reduction. These methods help simplify assembly and reduce labor hours, but they do not eliminate material or logistics costs. In addition, Tesla would have to invest heavily in research and development to ensure that the Model 2 maintains the brand's standards in safety, connectivity, over-the-air updates (OTA), and features like autopilot. All of this requires capital, and consequently, needs to generate a return. Reliable sources indicate that the most realistic starting price for the Model 2 will be around $17,979. This price tag best balances production costs with a minimal profit margin. Still, hitting anything below $18,000 remains a huge challenge given current supply chain conditions and global material prices. Elon Musk himself has said that the Model 2 will be a low-cost EV, but not necessarily an ultra-cheap car. That distinction suggests a price range of $18,000 to $20,000 is more plausible. To deliver a competitive car within this range, Tesla is betting on 4680 battery technology with dry electrodes, a project in development since 2020. These cells promise to reduce the cost per kWh by up to 50%, in addition to increasing energy density, improving autonomy, and acting as a structural part of the vehicle, reducing complexity and manufacturing costs. If these batteries are successfully implemented in the Model 2, they could make Tesla's dream of creating a high-performance, affordable, and popular electric car a reality. Computer models and recent industry data indicate that the 4680 dry electrode cells represent a major leap forward not only in economics but also in performance. While traditional lithium-ion batteries cost around $200 per kWh, Tesla's new cells could bring that cost down to around $100 per kWh, a crucial difference that could make the Model 2 a game-changer in the electric vehicle market. With the adoption of the 4680 dry electrode battery technology, Tesla has achieved significant advances in energy efficiency and productivity. The company estimates a 15% to 20% reduction in energy consumption, a reduction of up to 40% in manufacturing time, and a reduction of approximately 30% in the area required within the factories. In addition to operational savings, the new cells offer a higher energy density, reaching up to 310 Wh per kilo, compared to the average of 269 Wh per kilo of conventional lithium batteries. This increased density allows the Model 2 to achieve competitive range even with a relatively compact 53 kWh battery pack. This means that instead of increasing the size or weight of the battery pack, Tesla is able to keep the vehicle lightweight and efficient. The result is improved performance, acceleration, and energy efficiency per kilowatt-hour. The 4680 cell technology goes beyond the concept. The practical benefits are already visible. For example, with the same 53 kW capacity, a battery pack with 4680 cells can reduce the total weight of the car from 1,800 kg to approximately 1,630 kg, a reduction of 9.4%. Still, the range jumps from 300 to 350 miles, about 560 kilometers, proving that energy density makes a real difference without the need to increase the size or cost of the battery. In practice, this advancement allows savings of up to $25 per mile of autonomy. A concrete example was the transition of the Tesla Model Y, which by replacing 2,170 cells with 4,680 cells, saw the cost of the battery reduced from approximately $10,000 to $8,600 in a 75 kWh pack, representing a savings of $1,400 per vehicle, while maintaining the same energy capacity. The same impact is expected for Cybertruck production. With the full use of 4680 dry electrode cells, the expected reduction in production costs per unit is up to $5,500. These figures highlight the essential role that battery innovation plays in Tesla's strategy to make electric vehicles more affordable while maintaining the company's profitability. This is precisely where the Model 2 comes into its own. The combination of mass production, strict cost control, and the pursuit of greater autonomy requires a solution like the 4680 batteries. Although Tesla has not yet officially confirmed the use of this technology in the new model, everything indicates that it will be adopted, especially if it is fully developed by 2025. The Model 2 could even become the ideal platform for the debut of this technology on a large scale. Another factor contributing to making the Model 2 more affordable is Tesla's strategic approach to repurposing existing Model 3 and Model Y assembly lines. This reduces investment and speeds up production. The car's design will also be more streamlined, eliminating superfluous elements but without compromising essential features and performance. One of the biggest cost-saving innovations is the use of the Giga Press casting system, which allows the creation of large structural parts of the vehicle in a single piece. This reduces steps in the assembly process, and consequently, associated costs. In addition, Tesla plans to cut premium features, such as heated seats, ambient lighting, and luxury upholstery, from some entry-level models, while maintaining the possibility of upgrades after purchase for those who want customization. While often compared to the Model Y, Tesla is clear that the Model 2 is a standalone project, not just a scaled-down version of another model. Positioned between the Mini and Model 3 in size, it's designed to excel especially in urban environments. Despite having a less powerful motor, Tesla's efficient powertrain ensures excellent agility and quick response when accelerating. But how is the Model 2 hiding such game-changing features? Tesla recently surprised the tech industry by quietly introducing a new software feature. Unlike innovations focused on performance or speed, this new feature highlights a vital but underexplored feature: emergency siren detection. This system allows the car to automatically identify sounds of emergency vehicles and alert the driver almost instantly. In the Model 2, scheduled for 2025, this feature could significantly improve safety levels, up to 27% more than its competitors in the same category. The detection works in both manual and autopilot mode, allowing the car to react effectively to nearby ambulances or patrol cars. The technology uses internal microphones to capture sounds within the 2 to 4 kHz range, exactly where sirens, alarms, and other critical sounds are concentrated. taking advantage of the natural sensitivity of the human ear. And even in noisy environments, this type of sound is difficult to drown out by traffic noise, which usually occurs at lower frequencies. Tesla's system filters out ambient noise and accurately identifies important audible cues. Once detected, the system automatically reduces the volume of the sound by up to 70%, displays a visual alert with the direction of the emergency vehicle, and adjusts the route through integration with autopilot. The most impressive part? All the processing is done locally in the car. No audio information is sent to external servers unless the user manually authorizes data sharing. What sets it apart from conventional technologies is its ultra-fast response time, under 0.8 seconds, and its integration with multiple vehicle systems such as Sentry Mode and the 8 assistive cameras. NHTSA tests show accuracy of up to 94.7%. For comparison, models like the Chevrolet Bolt and Hyundai Kona Electric offer only collision warning, lane departure warning, and cross-traffic sensors, but no system that actively responds to real-time audible signals. The Model 2, even with a price tag of under $25,000, aims to deliver high-end features normally reserved for premium vehicles. And best of all, the hardware required for this feature costs only $15 to $20 per unit, allowing Tesla to maintain profit margins of around 22%. In addition, Tesla has been preparing important updates to both software and battery for the launch of the Model 2. The expectation is that in-cabin voice recognition will soon be activated via over-the-air update. However, this already raises privacy concerns. Organizations such as the Electronic Frontier Foundation have warned of the risks, and Tesla plans to adopt measures such as a physical switch to turn off microphones, end-to-end encryption, and compatibility with Hardware 4.0 to run multiple neural networks without affecting autopilot. In the battery field, Tesla is betting heavily on innovation. The Model 2 could feature 46 and 80 dry electrode cells, or even some early form of solid-state batteries, seeking greater energy density without increasing cost. The idea is to maximize autonomy per kWh and optimize system performance, something vital for urban users or in regions with few charging points. Technologies like ultra-fast charging have already been demonstrated with the Cybertruck and the new V4 superchargers. If applied to the Model 2, the impact could be huge. An affordable car with good range and fast charging, further narrowing the gap between electric vehicles and combustion models. Now the question remains, will the Tesla Model 2 really hit the market for less than $18,000? Would you choose it over a Chevrolet Bolt or Hyundai Kona if it came equipped with a 4680 battery and emergency siren detection with a 0.8-second response time? Thanks for watching. If you want to continue exploring the latest from Tesla and electric vehicles like this video, share it with your friends and subscribe to the channel. We appreciate your support and see you next time.